Let's move on to something really easy but something really important, that is how to calculate rate from the given ECG. So what I'm going to do is I'm going to take a 1 second pause and I'm going to draw two beats of a normal ECG, two successive beats of a normal ECG. So these are two successive beats that I drew. This is a P wave, this is a QRS complex, and this is a T wave, and similarly this is a P, this is a QRS complex, and this is a T wave. Now what I want you guys to focus on is this interval from R wave of one ECG to the R wave of next ECG. That is something called as RR interval. Now as you might have remembered, the speed of recording in an ECG is 25 millimeters per second, which tells us that 5 large boxes is equal to 1 second, and 1 large box is equal to 0.2 seconds, and 1 small box is equal to 0.04 seconds. I wanted to refresh you guys' memory for that because it's going to be quite essential right now. So I'm going to erase everything that I have drawn and show you guys how to calculate the rate. Now there are two formulas to calculate rate. Number one is 300 divided by number of large boxes between two R waves, and the other formula is 1500 divided by number of small boxes in two successive R waves. Now it's very easy to remember them because, as you might be remembering, 5 large boxes is equal to 1 second. So a minute consists of 60 seconds. So 60 times 5 is equal to 300, which tells us the number of large boxes that will be there in 1 minute. Similarly, one large box consists of 5 small boxes. So 5 times 300 gives us a number of 1500, which is number of small boxes in 1 minute. I want you guys to write down these two formulas, and I'm going to erase what is written on the screen. I'll take a 1 second pause for you guys. Now what I'm going to do is again draw two successive beats of ECG. If you see, there are approximately three large boxes between these two successive R waves. So if we were to calculate rate of this ECG, that would be 300 divided by 3, that comes out to be 100. But if you look carefully, there are 16 small boxes. So 1500 divided by 16 gives us a more accurate value of 94, which tells us that this is relatively less accurate formula as compared to this one. But you might want to remember both of them, as this one will be useful in diagnosing if the patient has tachycardia. However, this one will be the one that will help you quantify it. Now again, I'm really sorry guys, but I'm going to erase everything on this slide to tell you guys a simpler, perhaps a very simpler method to calculate rate. Now I have drawn these in different colors because I want to explain a very important concept. Now if you substitute in this formula 300 divided by number of large boxes between two RR intervals, values like 1, 2, 3, 4 and 5, what you get is this pattern, that is 300, 150, 100, 75, 60 and 50. So what I want you guys to see is, once one QRS complex has appeared, I want you guys to see when does the next QRS complex appear. If it appears after one large box, the heart rate is 300. If it appears after two large boxes, the heart rate is 150. If it appears after three large boxes, the heart rate is 100. If it appears after four large boxes, heart rate is 75. If it appears after five large boxes, the heart rate is 60, and if it appears after six large boxes, the heart rate is 50. Now the two values that I want you guys to focus on is this 100 and 60, because those will tell if the patient has tachycardia or bradycardia. So if you see a patient in which first QRS complex appears here and the second QRS complex appears before the third large box, that is somewhere around here, you can comfortably tell that the patient is in tachycardia. If, however, the second QRS complex doesn't appear till this point, you can say that the patient has bradycardia. So by definition, tachycardia is equal to heart rate of more than 100 and bradycardia is equal to heart rate of less than 60. So that's how I remember it. I'm sorry I spent a lot of time on this slide, but it's very important to understand these concepts. Now let's move to the rhythm. Again, I'm going to draw two QRS complexes. Now, in this case, what I want you guys to do is to look at multiple QRS complexes and look at the RR intervals. Now, in this case, if I draw a next QRS complex here, and the next one here, and the next one here, I'm sorry for my really terrible drawing, but just consider this as being a normal QRS complex. If I measure the RR interval, I can tell that it's pretty much constant, that is two large boxes. If the RR interval is constant or it's the same in the successive beats, we say that the rhythm is regular. Now I am going to erase this to demonstrate something called as irregular rhythm. If I see RR interval like this, if the R wave is here, one R wave is here, the second is here, the third however comes here, the next one comes later like here, and the next one comes later like here, it tells us that the RR intervals are constantly changing, which means that the rhythm is irregular. We see irregular rhythm in various arrhythmias like atrial fibrillation and many more, which I am going to talk about in detail in the arrhythmias lecture. So the bottom line for this slide is RR interval, if it's same or if it's changing. If it's same, the rhythm is regular, and if it's changing, the rhythm is irregular. That's all I want you guys to remember. Now, what all very basic things that we should look for at the first glance at the ECG? Number one is rate and rhythm, which we have talked about. Number two is sinus rhythm or not, which we already talked about. Number three is axis, which we briefly talked about, but I want to talk about axis in detail in my next videos. Then all these concepts, all these things we will cover in the later videos, but for right now I want you guys to focus on these two, the rate and rhythm and if sinus rhythm or not. So let's move on and practice a few ECGs. Now, how a normal 12 lead ECG looks like. So the first thing I want you guys to notice is this, that is, what is standardization? So what we see is a rectangle of height 1 centimeter, denoting that 1 centimeter is equal to 1 millivolt. Now what else do we see? We see for rate and rhythm and if in sinus rhythm or not. So how I go about it? First of all, I would like to tell you guys about what we see in this ECG. So this is a P wave, this is a Q wave, this is a R wave. S wave is not quite seen in this ECG, but if seen, it would be something like this. Then this is the T wave, and this is a TP segment, and this again comes a new P wave, Q wave, R wave, S wave is not again seen, and T wave. So this is how a normal ECG looks like. Now to calculate rate, let's calculate rate in this. So if this is our first QRS, this would be 300, this would be 150, this would be 100, this would be 75, and this would be 60. So you can roughly say that the heart rate is somewhere between 75 to 60 in this ECG, which is again a normal heart rate. Then if you were to look for RR intervals, that is for rhythm, let's say this is one RR interval, this is another, this is again a RR interval, and this is, so we have marked the successive RR intervals, and we can pretty much say that these RR intervals are not changing, they look pretty much the same. So the rhythm is regular. Then I want you guys to notice if the ECG is in sinus rhythm or not. So we see that in lead 1 and lead 2, the P wave is upright like this, like this. Each P wave is followed by a QRS complex like this, and heart rate is between 60 to 99. As we figured out in this case, it is between 75 to 60. You can go into detail by calculating the small boxes, but I would not recommend it at this stage, because in a normal heart rate it really doesn't matter how much it is. I mean, it may matter in some circumstances, but in a normal ECG it will probably not matter as much as figuring it out that the heart rate is between 75 to 60 and the ECG is in sinus rhythm. Now let's practice what we have learned till now. Now ECG is all about practice, practice and practice. The more you practice, the better you get at the ECG. This is the same ECG that we discussed in the previous slide, which had heart rate between 75 to 60, rhythm that was regular, and the ECG was in sinus rhythm. Now let's move on to the next ECG. Just looking at it, you can say that something's not right. Let's figure out what is it. So approaching by our traditional way, let's see what we can say about the rate. So this is the first R wave, say, and this is 300, this is 150, and this is 100. You can say that the heart rate is slightly more than 100, that is, the patient is having tachycardia. Then you can see that P wave is upright in lead 1 and lead 2, and each P wave is followed by a QRS complex, which tells us that ECG is in sinus rhythm, that the patient is in the sinus rhythm. And if at all you want to see, you can notice that this patient is having lead 1 which is negative, the QRS complex of lead 1 which is predominantly negative. If you remember from our slide on axis, the negative lead 1 means that there is a right axis deviation. So this is a ECG showing tachycardia that is in sinus rhythm and a regular tachycardia. It's basically a ECG of sinus tachycardia. Sinus tachycardia. What is it? We'll talk about in detail in our lectures on arrhythmias. Let's have a look at this ECG. Now we can see, to look for rate, we see that our first QRS, for example, comes just after this dark line. This would be 300, this would be 150, this would be 100. So we can conclude that the heart rate is slightly more than 100, which means the patient is in tachycardia. Then we can see that the P wave is inverted in lead 2, which means it is not in sinus rhythm. The axis is the lead 1 and lead 2, the QRS complexes are both positive, which tells us that the axis is normal. And one last thing, looking at the rhythm, if we mark the RR intervals, we can easily make out that the RR intervals are pretty much constant. So we can say the rhythm is regular. Now this is the second last ECG that we are going to practice. So what I want you guys to focus on is rate, rhythm and axis. So this is the first R wave. This should be 300, this should be 150, this should be 100, this should be 75, 60 and 50. So you can say the heart rate is close to 50, which meets the definition of bradycardia. Then the RR intervals look pretty constant to me. I mean, they are not changing by a large margin for sure. So that means the rhythm is regular. And looking at the axis, you can easily make out that lead 1 looks predominantly negative. So going back to our slide, if lead 1 is negative, it means that there is right axis deviation. Now there are multiple causes of right and left axis deviation that I am going to discuss in detail in the video on axis. Now this is the last ECG that I am going to discuss with you guys in this lecture. Let's look at the heart rate first. Let's consider this as our first wave, first R wave. This is second one. So there is difference of two large boxes between these two. So 300 divided by 2 gives us heart rate of 150. So this is ECG having heart rate of 150, which meets the definition of tachycardia. Then the RR intervals look pretty much constant to me, which tells us that it is regular. Then we just have to see for presence of P wave to comment about the sinus rhythm or not. I don't see any P waves in this ECG, which tells us that it is not in sinus rhythm. Then looking at the axis, we can see lead 1 that is predominantly positive and lead 2 that is predominantly positive, which tells us that the axis is normal. I want you guys to practice more and more ECGs to get used to this pattern. Thank you for watching my video. If you like my videos, please like, subscribe and share them. I will be posting a series of videos on ECGs and many other topics like arterial blood gas analysis and some tough and tricky topics in medicine and various other subjects like pathology, embryology that I found were really tricky to understand. If you have any questions, concerns or doubts, please feel free to reach me at the following email address, that is love.intmed@gmail.com. I wanted to take this opportunity to thank these people, Dr. Frank Janowitz, for allowing me to use the ECG from his website ecg.utah.edu. It is named as ECG Learning Center. I will highly recommend you guys to please visit the website and look at the ECGs. I am providing the link to the website in the description part of this video. Then again, Dr. Dean Jenkins of ecglibrary.com. I am again providing the link to the website. Then I would like to thank three of my friends that have helped me tremendously, Dr. Pranav Patil and Dr. Aditya Tolat, for their valuable inputs in designing this presentation. And Dr. Pratima Patil, special thanks to her for designing this wonderful logo for my channel. Now comes the very important part. I like to conclude all my videos by the next slide, by remembering the motivation for me to come into the field of medicine. That is my uncle, Dr. Sanjay Tiwari. He passed away in a tragic accident on 18th of May 2015. I used to call him Dr. Chacha, and I just want to give a message to him that he is always with me and he is being missed every single moment. Thank you guys, and I wish you best of luck.